Hi, everyone. My name is Mike Nakhimovich. I'm the Android lead at Nike's Digital Innovation Lab in New York. And I'm here today to talk about UI navigation. At least, that's what I plan to talk about today. I submitted this talk about UI navigation, but as I started working on it, I started realizing that it's not just UI navigation that I'm going to be talking about. I'm going to be talking about a less specific topic of dispatching state and how navigation is just a reaction to the state of your application. So I'm not going to be talking about any library in particular. I'm rather going to be talking about patterns and then show you a sample project or link you to a sample project at the end that'll show you what's possible when you start treating all interactions in your app as a state change. So all Android apps have a UI. And a UI is usually made up of many different views. So we have a search view where someone can type something. We have a result view, which we can then show results to the user. Because it's a real app, we could also have an error view and a loading view. And even a UI that's as simple as just showing results really is made up of 4 different views. And then we'll have a user which will interact with our UI. When a user interacts with our UI, it'll lead to a state change. We're going to go out to the cloud. We're going to download data. When we do this, we need to show a loading indicator. When the results come back, another state change. Now we need to show the results on our screen. And somehow, these state changes need to be rendered in our UI. So let's take a step back and actually talk about state. What I mean when I say state. To me, state is a representation of your UI at a certain point in time. It's what determines how your UI is going to render and how it's going to behave. Your state should be deterministic. A certain state should lead to a certain UI. Unfortunately, and this is where I really struggle, Android does not have good patterns for working with state. We don't know how to create state. Passing state is difficult. Similar, where do we hold our state? Where do we maintain it? And that all can be summarized as, how do we think about state as an Android developer or as a community? So before, I used to think about state this way. I used to think that every one of my screens is going to have a screen state model. So here we have a data class, which holds a bunch of variables that each determine the state of particular parts of my UI. So I'll keep something for my search results. I can even keep my search term and flags like whether I'm loading. This works well when we have a simple UI, but as our apps get funded and we add more and more screens to it and add more and more complexity to each screen, we have more and more state to manage. And to me, this starts feeling like a God class. We have a class where we are holding many variables that may not be related to each other. I don't like God classes. They make all my coworkers really angry at me. As a community, as an Android community, we love being reactive. We have rxjava. Even data binding, we can observe changes in it. Overall, we like the concept of reacting to something rather than asking or pulling for that information. So that's how I started thinking about state. Lately, I've been using a centralized dispatcher to model my state, not as a single class, but as a stream of individual state changes. When I talk about a dispatcher is a very simple concept. It's nothing more than an object that can receive messages and send them. In my case, our dispatcher is going to be dispatching messages about state. And that's what our UI is going to be reacting to. So why? Why do we want to do this? Why do we want to have a state dispatcher? Most importantly, it will allow us to decouple the producers of state, the things that change our state, from the consumers that care about that state change. So come on a journey with me. I'm going to talk about how I got from just wanting to talk about navigation patterns to actually representing everything as a dispatcher. So we had our example. A user will type a search term. They'll click search. Once they click search, we have that state change I talked about of having to show the loading screen, followed by that result screen. And how can we do this? How can we have our search view, our result view, and our loading view all talk to each other? The first approach, and I used this for years, was to make some sort of presenter or some kind of container that owns all of the views. When there's only a few views, this works well. I can make a pizza screen presenter. It can have a reference to both my search view and my result view. And it can pass data between them and act as the bridge. But I don't know about your product people. My product managers love our apps getting better. So they like to add new screens and new functionality as we go. So now we have 3 views that our presenter needs to manage. That's still OK. These are all related. It's a loading, a search, and result view. But what happens when your app gets that billion-dollar funding that we're all craving, and you want to add additional screens? This is where it gets unwieldy. Your homepage could have a cart. It can have a profile tab, drawers, loading screens, search views. And we can't manage all this in a single object that's going to own all of them. Because again, we're going to start dealing with God classes. This whole having a presenter for a screen doesn't seem very scalable to me. And it's something that I always struggled with. And I struggled with the hierarchy of presenters that own other presenters. And it never felt right. So back to the drawing board I went. Why don't I instead just create listeners? Why don't I have my views listen to each other? The result view can listen to my search view so that my search view can push the results anytime there are new results. And this felt nice. It felt more like a push rather than a pull. I'm not setting a variable. I'm actually transmitting the data that I need. And again, it starts to break down as you get more screens, as you get more views. So we had our result view, our search view, and our loading view. Well, what if our search view needs to listen to our result view to know when to show? And our search view also has to listen to the loading view, because maybe you don't want to allow a user to search while you're already loading something. Similar, maybe you want to use your loading view for both the search view and the result view anytime an action happens. And then we get a circular dependency. And this circular dependency makes it really hard to test your code and makes your coworkers not like you very much. So our last proposal, how I'm currently doing things. I'm using a centralized dispatcher for all of the state changes. I have this dispatcher, which is now responsible for both receiving the state changes and emitting them. But back to the question of why. I showed you that the other ways don't quite work. Why do we need a state dispatcher? Sorry, too much partying last night. OK. The reason we want to have this dispatcher is because we want to decouple all our views from each other. Our result view would only communicate with the dispatcher, similar for our loading view and our search view. This way, our UI can create new state, and our UI can react to new state. Think of it as a cycle. And we can have the cycle without having any hard references between our different UI elements. And just like the listeners, we can push our state rather than polling for it or asking for what the state is. So there's been other talks about reactive state. I've actually attended a few, but they all seemed very theory heavy to me. There was never any implementations that I can use myself. I'm going to change that. We're going to start building up a dispatcher that can deal with our state changes. The first thing we're going to do is represent each one of our individual states as its own data class. Kotlin is perfect for this because we can make a sealed class state that all of these data classes are a part of. State should be immutable. You should only be able to create new states, never change your existing state. And now that we have a representation of individual states, we can create a dispatcher that simply can dispatch every one of these states and create a stream. I'm going to use rxjava for this so that we can observe particular state changes that we care about. Anytime the UI needs to change, we can dispatch a new state, like showing results, show loading, or show error. When the state changes, our views, our presenters, our view models, it doesn't matter what architecture you go with, can listen to the particular state change that they care about. So here, I'm only listening for the state results. I get the data out of that data class that I had, and now I can pipe to my view or tell my view what it needs to do. So rather than coupling our search and result views together, we can decouple them with a centralized dispatcher. Let's take a look at how this will behave visually. First thing, we'll have a dispatcher. It'll be centralized. Our result presenter, and again, it's not important that this is a presenter, it's just how I work with it, will subscribe to only the showing result state change. Our loading presenter will subscribe to only the showing loading state change. And now, when the search view passes a new search term to our search presenter can dispatch a show loading state. Our dispatcher can find who is listening of a state of that type, and it can then pass that state to our loading presenter that cared about that state change. The loading presenter is now free to do what it wants with that state change. Continuing, our search presenter goes up to the cloud, downloads data. Now that it has its data, it'll dispatch a showing result state change. This time, the result presenter is what cares about it, and our result presenter will now get our showing result state change and be able to pass those results to its view. The nice part about having a centralized dispatcher that all of your views use is that you can have multiple views or presenters listening to the same state change. Because when I'm showing results, I actually want to perform multiple actions. It's not that I only want to tell the result presenter to do something. I actually want to tell the loading presenter to hide itself while the result presenter is going to tell its view to show itself. Even though there was only a single state change, I can have different actions that are going to be a result of that state change. Back to code. My presenter would subscribe to the state result state change whenever it attaches to the view. My search presenter, whenever someone searches for something, can go up to a store or an API, get the data, and then dispatch that state with the payload that anyone that cares about that state change is going to want. The important thing to notice here is that each of these functions is not talking to each other directly. Like I said, consumers and producers of state changes are going to stay decoupled from each other. So how will this data flow? When show results gets the results, it'll go through our dispatcher, just like it did in our last example. It'll go to our result presenter. Maybe you'll have a second result. This is why it's nice that this is stream-based. We'll be able to push it to our result presenter again. But now, our result presenter may actually want to be able to add things to a cart. So rather than our result presenter needing a hard reference on the cart, we can continue this relationship and have our result view dispatch a add to cart state, which our cart presenter will then get. Notice that our result presenter is both a consumer and a producer of state. And it only needs to interface with our dispatcher to be able to do this. So this is nice, but really what I'm showing you is just a glorified event bus that I'm passing data around with. Data isn't the only thing that is going to need to be passed around in your app. You're also going to have to tell views, like I did at first, whether they need to show or hide. So as an example, we have a cart button on the bottom. And when someone clicks this, we want to show our cart. And when we show this cart, we need to do this in a manner where our home screen doesn't really need to know how that cart is going to get that message. We're now going to start combining our states and making higher order states that we can listen for. So remember I said treat everything like a state. I'm going to treat the cart as nothing more than a cart state. I'll then create another state called a showing state, which takes any other state as its input. This allows me to dispatch state showing cart, and it also allows me to add a few helper methods to my reactive stream. This is nothing more than just filtering on a showing state, which I can then subscribe to. And I treat this as showing, something you can subscribe to for passing in a state, or showing not, which would be called every single time any other state goes through showing. So our cart view can listen for both when it needs to show itself and when it needs to hide itself by just saying, give me the state, let me know when someone wants to show me or hide me. So when I dispatch state.showingCart, it'll hit that first function on top. But if I dispatch state.showingCheckout, I can hit that function on the bottom, or that stream on the bottom, and now start hiding my cart view because I need to actually start showing the checkout on the bottom. And this works great for the types of apps or the types of screens where you have many different views. But it seems like that's not the only pattern that we really see in UI. This only works if all of your views are attached to your hierarchy when you are getting started. And that's not a really scalable way to build your apps when you have lots and lots of screens. Maybe you have registration. Maybe you have checkout. How can we model these deep flows using states? Well, like I said, let's treat everything as nothing more than a state change. Let's treat the screen creation and routing from one screen to another as a state change. So this was actually supposed to be what I was going to talk about my whole talk, but to me, it feels like the end of a journey that I was on. Let's look at this dispatching screen workflow. So we have our cart view, and our cart view has a checkout button. When someone clicks checkout, our cart view is going to tell our cart presenter it needs to go to checkout, and our cart presenter is now going to dispatch a screen.checkout state. Now, up until this point, the only thing I showed you that is listening for these state changes are views or presenters that own the views. But it doesn't have to be that way. We can have other constructs, like screen creators, that can listen to particular state changes. And what we can do is have our dispatcher wrap states in other states. So it may be a little hard for people in the back to see, but our dispatcher took our screen checkout state and changed it to a creating state, which contains the screen.checkout state. That state is being listened for, all creating states, by our screen creator, which creates our checkout view, creates a checkout presenter, and attaches the checkout presenter to the dispatcher, listening for showing checkout, checkout screen states. Next, our screen creator can dispatch a showing screen state, taking that initial screen state we had before that we wrapped into creating, unwrapping it, and now wrapping it in a showing state. And that showing state is what our presenter was listening for. And when our presenter gets this showing state, What's really neat about this is that that initial screen.checkout data class that our cart view made is what gets propagated to our presenter. So if you had inputs, if you had variables that needed to be passed to the screen so you can show it, you can pass them. And that's the data that now is flowing through your dispatcher, through your screen creator, through your presenters or view models, and down to your views. From a coding perspective, view calls presenter open cart. Sorry, it should be presenter go to open checkout. Dispatcher will make a new screen state. Screen state is just another state that is within the state sealed class. It'll dispatch screen.checkout. The dispatcher will know that it needs to wrap any screen state in a creating state, which our screen creator can then be listening to any of these creating states that we can achieve by filtering the other states that we had. Once our screen creator is done creating a screen, we dispatch the showing screen state, which goes back to our dispatcher. Our dispatcher will do two things. It'll first add the state to a backstack. More on that later. The backstack is nothing more than a Java or Kotlin stack. And it'll push through our reactive stream that showing state. That was the state that our checkout presenter was listening to. It is able to get that state object and be able to tell its view that it needs to show. That's what I mean by UI navigation as a state change. Screens become nothing more than states. You can have a search screen, a cart screen, a checkout screen, a payment screen. Doesn't matter. They will all work the same. They're either going to be objects with no inputs, or they'll be data classes that'll have any of the inputs or any of the preconditions that are needed for that screen. And routing will become nothing more than a state change. We can go to search by just dispatching a screen state. We can go to cart by dispatching a cart state. If we ever submit names, and when we do that, we need to go to checkout payments, again, we're just dispatching the screen that we need to go to. Forward, this works really well. But what happens when you need to go back? That's where we had that stack of states, and this is where we're going to leverage it. Our dispatcher can have an additional function, go back, which we can hook into from our activities on backpressed. When go back is executed, or when it is called, our dispatcher will pop the current state off our stack, pop the previous state off our stack, and it will redispatch that previous state. And now we'll be able to go back to the previous screen that we were on before this. And you'll be able to navigate forward and backwards as much as you want. Even if you have an app that looks like a tree and you're going into different branches of it, you'll always be able to get back and then navigate anywhere else you need. Your state stack becomes your back stack. And your back stack becomes your state stack. Everything, including routing, will become a state change. No matter which one of these cats you want to go visit, you can do that, and you can achieve that by just dispatching whichever screen you need to go to. And I found those are all the interactions that Android apps have. We either pass data, we pass messages that tells us to toggle things on and off, or we go from screen to screen. By treating every one of those view interactions as a state change, your UI can become a representation of dispatch state, which, plot twist, is dispatched by your UI. So overall, I want you all to come out of here thinking about your app and user interactions as nothing more than a cycle. User interacts with a view. The view dispatches a state change. The view reacts to that state change. and user interacts with that view again, which starts our cycle again. So I know this was a lot of information to take in. It was a lot of slides, and I went pretty fast. But I also have a sample project that you can all refer to that'll show you this concept and actually have a bit of a larger app built. And I just wanted to give a big, big thank you. I reached out on Twitter. So I'm not much of a UI developer. My UIs are pretty laughable, actually. So I reached out on Twitter to the Android community. And a great developer, Effatary Money, said he was delighted to help me with the UI. So big thank you to him for making this sample app look a way that I'd be proud to share with everyone. Thank you.